This is the brief on electrostatic potential and governing equations. So in electrostatics, it's really all about figuring out this invisible energy field called the potential. You know, the thing that drives electric forces. Turns out, by simplifying things, physicists came up with two fundamental equations that govern this potential: Poisson's and Laplace's equations. Okay, so let's get right into the core distinction between these two key field equations. First up, we've got Poisson's equation. You use this one when the area you're looking at actually contains electrical sources, which we call charge density. This equation basically tells us that the potential field is directly linked to the amount of charge inside. It defines how the electric field radiates outward from that source, a lot like the field you'd get around a single point charge. Second, there's Laplace's equation. Now, this is what you use when you're in a completely charge-free region. Since there's no internal source, the potential is determined entirely by the external boundaries, so the fixed voltages you set on the edges of the space. The field inside has to be smooth and stable, so it just ends up averaging the potential values from those external limits. You can kind of picture it like stretching a rubber sheet between four fixed points. So the whole difference just boils down to whether your potential field is defined by internal charge sources, that's Poisson's, or purely by its external boundaries, and that's Laplace's.